Hello and welcome to Dynamics 365 Universe, where we decode real-world problems and turn them into elegant, high-performing solutions in Microsoft Dynamics 365 Finance and Operations. Today, we're diving deep into a performance optimization that boosted our cost-price calculation from sluggish to blazing fast. If you've ever written logic that loops through records and updates them one by one, this video is for you. Let's jump in. The problem: old code that was too slow. Our goal was to update the cost price field for a custom table, named as D365 Invent on Hand. In the older approach, the code looked like this. For each record in D365 Invent on Hand, call a method named Calculate Cost Price. Inside that method, dynamically build a query on the invent sum and invent dim tables. Fetch sum totals, compute cost, and update the record. Sounds fine, right? Well, not quite. Here's what was going wrong. It executed one query per record. That meant thousands of SQL calls when updating large datasets. There was no grouping, no caching, and redundant calculations happening for the same item site location combinations. Result? You guessed it, poor performance and high resource usage. The optimized solution. Now let's talk about how we fixed it, and why it's so much faster. Step 1. Group your data. Instead of querying invent sum per item, we wrote a single SQL-like select that summed up posted QT, deducted, received, posted value, and physical value. Grouped data by item ID, invent site ID, and invent location ID. Filtered out transit warehouses using an inner join with invent location. This lets the SQL engine do the heavy lifting, returning aggregated results in one go. Step 2. Calculate and cache. We calculated the cost for each group using this formula. Cost equals absolute, posted value plus physical value, divided by total quantity. Then we stored the result in a map, with a composite key combining item ID, site, and location. Step 3. Efficient updates. Next, we looped through all matching records in D365 Invent on Hand, and for each one, looked up the cost in the map. Updated only if a match was found. All wrapped in a single TTS begin, TTS commit block for efficient database handling. Let's break down a small but crucial piece of logic from our service class, and that's the key generation function used to uniquely identify item records during our cost price update process. The purpose of the key. When updating large sets of inventory records, we needed a way to uniquely identify each combination of item ID, site, and location, since the same item might exist at multiple sites or locations with different cost prices. Instead of creating a complex object or using multiple fields as keys in a map, we simplified the process by concatenating all three into one readable string. This gives us a human-readable, easy-to-debug key that we can directly use in the map. Why not use multiple strings as map keys? Maps in X++ accept a single key. That's the key design constraint. You can't pass three individual strings or values as a key, so we have to combine them into one single value, and strings are the most flexible format. Hence, item ID pipe symbol site ID pipe symbol location ID. This format ensures uniqueness and maintains readability. Why this is way faster. Here's why this approach wins. One query instead of thousands. Uses SQL group by for max performance. Eliminates repeated calculations. Reduces memory and CPU usage. Cleaner, more maintainable code. Developer tips. Here are a few best practices this approach teaches us. Avoid querying inside loops. It's a silent performance killer. Group and aggregate data using SQL, not X++. Use maps for quick key-based lookups. Always filter out irrelevant data early, like transit locations in our case. Don't forget to profile and measure. That's how we realized the old method was slowing everything down. Real impact. With the new logic in place, the cost price update process went from hours to minutes, especially on environments with large volumes of inventory transactions. It's the kind of transformation that makes a real difference in production environments. So next time you're dealing with heavy data processing in Dynamics 365, ask yourself, am I working with records one by one, or can I think in sets? This shift in mindset can massively boost your performance and scalability. Thanks for tuning in to Dynamics 365 Universe. If you found this helpful, don't forget to like, share, and subscribe for more real-world tutorials and optimization stories. Also, drop a comment below if you'd like the full code, or want us to convert this into a size operation batch job for your project. See you in the next one, and keep building smarter with Dynamics 365.